Welcome and thank you for joining. In this video, we'll take a look at a trig identity. It requires the use of compound angle formulas, and this is exactly what we've been working on in the last couple of days. Let's read the question first. We have sine of C plus sine of D equals 2 sine of C plus D over 2 multiplied by cosine of C minus D over 2. Whenever I prove a trig identity, first I name the sides of it, so as the left side and the right side. Next, we have to make a couple of decisions. So please remember, before you make decisions, please remember that when we prove identities, we prefer to work with one side of the identity and simplify it until we get to the other side. And when we do that, we usually prefer to work with the bigger side because you can always make something bigger into something smaller and simpler. However, there are cases when we can work on both sides simultaneously, but remember that it is very important that when we simplify each side, we simplify them separately and we never transfer terms from one side of identity to the other because that spoils the entire idea of proving something. So I have to make a decision, and if you want to think about it, or if you want to guess which side am I picking, you probably have to consider the size of each side. So the right side of the identity seems a little bigger, so I'll start working with it. And I like to write the expression first because I get to see what terms I have. When you write things down, you kind of, ponder on them and you can see what you're working with. So next we have to think, what are the things that I can do to this expression? Well, we are working with compound angle formulas, and what we see in here is compound angles, but they don't appear in the exact same form we have seen them in the formulas. In the formulas, we usually have, say for example, the sine of A plus B, which we know that would equal sine of A cos of B, and then plus cos of A sine of B. So what we have to do then first is break this angle down into the sum of two angles. So we'll write 2 times sine of C over 2 plus D over 2, and then multiplied by cosine C over 2 minus D over 2. So next, we'll apply the compound angle formulas for each part of the expression, and we'll get number 2 outside because 2 is a factor. We're going to get the sum of two terms in here and the sum of two other terms in here based on the formulas, and that's why we're going to need to keep 2 out, and we need big brackets here. So we're going to have sine of sine C over 2 multiplied by cos of D over 2. And then they will switch around. So sine of D over 2, the angle will switch. Cosine of C over 2, close the brackets. Now this will multiply. Cos C over 2 minus D over 2 would be cos C over 2 cos D over 2 plus sine C over 2 sine D over 2. Close the brackets, close the big brackets. So next we have to use algebra. So in order to expand and simplify. That's all we can do. We cannot use any other formulas to simplify at this point. So number 2 still outside, square brackets. And when we are multiplying here, remember that we have to look into the terms we have. So you have sine C over 2 cos D over 2. These are different. So we don't get, any special formulas that we used to have, for example, A minus B times A minus B. So that's not the case in our case. So because even you see that the angles and the ratios are completely different. So this will be a very straightforward, clean FOIL process. So we're going to go first term, outside terms, inside terms, last terms, FOIL. Here we go. So sine C over 2 cos D over 2 multiplying cos C over 2 cos D over 2. So you're multiplying these two together. Next, we have sine C over 2 cos D over 2 multiplying sine C over 2 sine D over 2. So this and this together. So the O, the letter O. Next, we have sine D over 2 cos C over 2. That is multiplying cos C over 2 cos D over 2. So these two together. So these are the inside terms. And now the last terms. We have sine D over 2 cos C over 2 multiplying sine C over 2, sine D over 2. Close the brackets. And look at what we have created. A very big, awkward expression. But have faith, it's going to get smaller. So next we have to think, what are the things we can do in this case? So if you look at each term or each group of terms closely, always identify, first of all, what you have created in here. It looks like it's a lot, but it's basically 4 terms added to each other. So we're going to check and see if we can simplify any of them. And we can simplify if we don't look into each group of terms and see if they have anything in common. So cos C over 2, cos D over 2, cos C over 2, cos D over 2. So sine C over 2, cos D over 2. Cos C over 2, cos D over 2. I see that I've repeated cos D over 2 in here. So these two multiplied together will give cos D over 2 squared. The rest is sine C over 2, cos C over 2. So this is common. Next, similarly, we have the sine of C over 2. The sine of C over 2 multiplying each other will make a sine squared C over 2. And then the other two terms. Now we are here. Sine D over 2, cos C over 2, cos C over 2, cos D over 2. These two are the same. We got to be very patient when we work with trig identities because they are very mysterious, but they can be very tiring as well. But at the end, they're fun. So continue with the last term. It's the same pattern. They're full of patterns, all trig identities. Sine D over 2, cos C over 2, sine C over 2, sine D over 2. Sine D over 2 is common. Okay, close that. So we've created some interesting, combinations in here. And now we're thinking, what's there now? What can we do with this? Again, it's all about observing every term. Feel the power of observation. Take in every term. Take a look at what they have in common, what they have different. So what we have in here is square terms everywhere, but they're very different from each other. So our focus will be on the rest of the expressions. Check and see what we have, if there is anything that can help us. As you can see here, you have sine C over 2, cos C over 2. Sine C over 2, cos C over 2. That means that these groups of terms have something in common. Something similar happens here. So let's get to work. We have to look for common factors, and we have to first bring these terms close to each other. And that's why I'm going this fast, because all I'm doing is rewriting all the terms, and I'm bringing close to each other only the terms that have something in common, anything in common. And next, we have to look for the common parts. Now we have to group them. Okay, and as we group these terms, we have to identify their common factors. I'm taking the long way in here, so I rewrote the entire expression. Right here, it's the same thing as in here, just so that we can identify just the common factors. We group them. And now it's time to factor. So we're factoring by grouping. So sine C over 2, cos C over 2 will be a common factor. And surprise, surprise, look at what we've created here. This gives us hope because, as you can see here, we recognize a very famous formula, one of the formulas that we cannot forget, actually, when we learn trigonometry. It's the Pythagorean identity. And we're hoping to get something similar here. Let's see what happens. So we have sine D over 2, cos D over 2 is common. So in brackets, we have sine C squared, sine C over 2 squared plus cos C over 2 squared. So I rearranged them again a little bit because I wanted to make this look exactly like the Pythagorean identity. Not a big deal. And close the brackets. So you probably know what our step will be now. So this will be 1, this will be 1. will take care of this. So we are looking for trig patterns and formulas. We recognize the Pythagorean identity. So we'll continue writing the expression now, but we no longer need to write the entire expression because we already know what that would equal at this point. So that would be equal to exactly 1. So we have sine c over 2 cos c over 2 multiplied by 1 plus sine d over 2 cos d over 2 multiplied by 1. So now we'll have to expand. And by expanding, I mean that we're going to bring number 2 in. So let's see what happens. So a little bit of algebra again. We have 2 sine c over 2 cos c over 2 plus 2 sine d over 2 cos d over 2. Now a little bit of imagination is required in here. Remember that our goal is to go back to the left side, which is sine c plus sine d. And if it helps, write down what sine c plus sine d would look like. So sine of c can be interpreted as c plus c divided by 2, which is sine c over 2 cos c over 2 plus cos c over 2 sine c over 2. You see that? Now, as you can see, these two are identical terms, or can we say like terms? So you can add them by giving coefficient of 2, which is sine c over 2 cos c over 2. And sometimes it's a good idea to go back and forth, left side, right side, just so that you can see a common middle point where you can create an idea of in what direction you would go here on the right side. So in what path is the left side leading us? And that can give us an idea of what to do with the terms we have. So now I know that this double sine c over 2 cos c over 2 is nothing but, I'm going to break each term into a sum, right? And that will bring the compound angle formula to life. And I did this with the help of the left side. Even though I didn't work with the left side, I didn't simplify it. But I looked at the left side just to get an idea of what other shapes or what other faces can the left side look like so that I can compare or I can match what I have in here with the left side. So I break this down and I do the same thing for the other term. And now we look for patterns again. And as you can see, we have arrived to almost the end of the entire story here. The right side is sine c plus sine d, and so is the left side. So right and left are equal. I hope you enjoyed this proof and work patiently, work with curiosity. Have fun. Bye for now.